Hello everyone. In continuation with the previous topic of finding rational numbers between given two rational numbers, we'll be looking into the questions wherein the rational numbers have two different denominators. In the previous questions, we saw that the denominators were equal. So the moment the denominators were equal, we looked into the numerator. But now we'll be talking about those fractions in which the denominators are not equal. So the first step will be to make it equal. Okay, that means we are going to make the unlike fractions. We'll convert the unlike fractions into like fractions. When we had the like fraction, we directly checked the numerators. If it worked out, we found it. If not, then we multiply 10 to the numerator and denominator. But if they are unlike fractions, like in this case, so what we'll do, the first thing is we are going to make it like fractions. Okay. So what is the LCM here? 24, because 6 and 8 is 24. So the denominator will be 24. That means I have to multiply this by 4 and 8 3s are is 24. So I'm first changing my unlike fraction into a like fraction, and that will change out as negative 20 by 24 and 15 by 24. Now I need to find 10 rational numbers. Now, since the fractions become like, that means the denominator is the same, I'm going to look into the numerator. The numerator is negative 20 and 15. So, very clearly, there are more than 10 numbers or integers which lie between negative 20 and 15. So, it's very easy for me to list out the 10 rational numbers. Okay, so the 10 rational numbers will be, I can take any 10, right? So, I'm going to take negative 19 over 24. Negative 11 over 24, negative 9 over 24, sorry. Then I can take any other number. Okay, I can even take 0 over 24. Okay, so negative 5 over 24, 0 over 24, 2 over 24, 7 over 24. I think I need 2 more, right? I can take 11 over 24 and 14 over 24. Correct? So if you observe, I've written the denominator same. So they have to be like fractions. Okay? Let's take the next one. Negative 2 over 5 and 5 by 2. So again, it's unlike fractions. So first let's make it like fractions. So what is the denominators? 5 and 2. What is your LCM? 10. So I'll multiply the first fraction by 2 and the second fraction by 5. So my fractions will change as negative 4 over 10 and 5 over 10. Okay, how many fractions do we have to find between negative 4 and 5? 10 fractions, 10 rational numbers, right? From negative 4 to 5, let's just quickly have a look how many integers lie. So it's negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. Are they 10? Let's count. 1, 2, 3, 4, 5, 6, 7, 8. They are not 10, right? I can't take negative 4 and I can't take 5. So this is not going to work. So what we'll do, we need to make the fractions even smaller. So how do we do it? We'll multiply by 10. Yes, we know that we already have 10, but still we are going to multiply by 10. So that will become 10 multiplied by 10 in the numerator and denominator 10 multiplied by 10. So am I making it a more smaller number? I mean smaller fractions, right? So we'll end up with negative 40 over 100 and negative 50 over 100. Sorry, positive 50 over 100. So I can take any 10 rational numbers between them. So I'm leaving that part for you, that you will list out any 10 rational numbers between negative 40 by 100 and 50 by 100. Let's take the next one. Again, 2 by 3 and 4 by 5. LCM will be 15. So it's 2 times 5 divided by 3 times 5 and 4 times 3 divided by 5 times 3. So I'm getting my fractions at 10 by 15, the like fractions, and 12 by 15. Can I find 5 rational numbers here? No, because between 10 and 12 there is only one number, that is 11. So it's not possible, right? So what I'll do, I'll make it more smaller. How will I make it more smaller? By multiplying the fraction by 10 in the numerator and denominator, both are multiplied by 10. So I'll end up having the fraction changed to 100 by 150 and 120 by 150. Now I have around 20 numbers between them because 100 and 120, right? So there are 20 fractions. I can write any of them. But yes, when you're listing them, the denominators for all of them should be same. So I can take 111 by 150, 109 by 150, 115 by 150, 106 by 150, and 119 by 150. So these are my numbers. You can select yours. Okay. So what is the key factor? First, we are changing the unlike fraction to like fraction. Then we are checking the numerators. If we can find the given number of rational numbers, then we stop there. But if we are not able to, then we make these like fractions even more smaller equivalent fraction by multiplying by 10, 10. And then we find it. Okay. Next, negative 3 by 2 and 5 by 3. Again, unlike fractions. So to make it like, I'll multiply 2 because my LCM is, no, multiply by 3, sorry, the LCM is 6. Okay. So I end up getting negative 9 by 6 and 10 by 6. Now, how many rational numbers do I have to find? 5. So it's very practically easy because it's negative 9 and 10. I need to find only 5. So my 5 rational numbers can be negative 8 by 6, negative 5 by 6, 0 by 6 is possible, 3 by 6, 9 by 6. Correct? I need to take only 5. So it's easy for me to list out the 5 rational numbers because between negative 9 and 10 I have to find, right? So it's easy. If they would have it be negative 9 and negative 10, then it's not possible. So here it's negative 9 and positive 10. So it's easy. Okay. Next. 5 rational numbers between negative 1 by 4 and 1 by 2. So again, clearly, unlike fractions, the LCM is 4. So I get my two like fractions are 1 by 4 and 2 by 4. Are there any rational number going to lie between? There will be many rational numbers lying, but we need to figure out. But between 1 and 2, we don't have any, right? So we are going to make it even smaller by multiplying by 10 to the numerator and the denominator. So we end up having 10 by 40 and 20 by 40. So from 10 to 20, in between 10 and 20, I can find many of them. So you can list out your own 5 rational numbers. It can be 11 by 40, 9 by, sorry, not 9. 11 by 40, there are only 10 possibilities. 11 by 40, not even 10, 9. 11 by 40, 12 by 40, 13 by 40. So you have the options, right? Next, again, 10 rational numbers between 3 by 5 and 3 by 4. Here the numerators are same, but not the denominators, right? So the LCM is 20. I should multiply this by 4 and the other fraction by 5. So I end up having 12 by 20 and 15 by 20. I need to find 10 rational numbers. Between 12 and 15, do we have 10 possibilities? No. So again, what we have to do? Make it a smaller fraction. How do we make it? Multiply by 10 to the numerator and 10 to the denominator. So now the fractions will become what? 120 by 200 and 150 by 200. Between 120 and 150, we have 30 different numbers. So any 10 you can select. Clear? Now this was easy because we had fractions. So what was our first step? Change the unlike fraction to like fraction. Once you get the like fractions, you check the numerators. If the numerators are really far away from each other, then it's easy to find the rational numbers that they are asking us to. But if the numerators are very closer to each other, then what do? You make them smaller rational numbers by multiplying it by 10 to the numerator and denominator. And then you find your desired rational numbers, the number of rational numbers they have mentioned in the question. Now, if you don't have a fraction, like here, 4 and 5, and they are telling us to find 3 rational numbers. So the best way to do is you just label the two numbers between, sorry, on a number line, like we do it. On a number line, when we come from 0, it always 4 on the left and 5 on the right. Okay, it's a little bit different method. So first, to find the first number, what you do is you add these two numbers, which is given in the question, and divide it by 2. So that is 9 by 2, which is a, yes, sorry, that will be a 4.5, or you can show it as 9 by 2. I'm going to keep it as a 9 by 2. And it's exactly the middle number between 4 and 5, which is 4.5. But I'm going to show it as 9 by 2. So this is my first rational number. To find the second rational number, what I'm going to do is, I'm going to find a number between 4 and 9 by 2. Okay, so what I'm going to do, I'm going to add 4 and 9 by 2 and divide it by 2. That means 4 plus 9 by 2 divide by 2. This is what I'm going to do. Okay, so in the numerator itself, I have to find the LCM. So it's 4 times 2 divide by 1 times 2 plus 9 by 2 divide by 2. Correct? Which will end up as 8 by 2 plus 9 by 2 divide by 2. Okay, which is equal to 17 by 2 divide by 2. Now, what will happen? This denominator 2, the numerator itself is a fraction level 17 by 2, and there is a denominator 2. So, if you really have to understand, this is more like 17 by 2 divide by 2. So, if I change it, it will 17 by 2 multiply by half, because when you change the division sign to multiplication, the next fraction changes into the reciprocal or the opposite, right? So, this will be a 17 by 4. Am I clear? So what did I do? I have added the cornermost number, that is 4, and the middle number, that is 9 by 2. And I have divided that by 2. So this is 7 by 4. 17 by 4, sorry. Okay. To find the next rational number, what I'll do? I'm going to take, I'm just going to make a box here. Yeah. So what I'm going to do is, I'm going to take the next two numbers, that is 9 by 2 and 5. Find the third rational number. Okay, so I'll do is 9 by 2 and 5. I'm going to add these two. Okay, so third rational number. Okay, so what I'm going to do is 9 by 2 plus 5 divide by 2. Again here we don't have, again here we have a fraction and a whole number added up, right? So that will change as 9 by 2 plus, I need to find the LCM, so 5 times 1 divided by 2, correct? That will be 9 by 2 plus 10 by 2 divide by 2, correct? So 9 plus 10 will be a 19 by 2, which is equal to 19 by 2 divide by 2, which is changing as 19 by 4. Okay, so what are we doing in this method? We are finding the middle number, exactly the half of it. Okay, let's take one more to understand it. I'm taking two numbers, minus 1, 0, and I need to find three numbers. So minus 1 and 0, and minus 1 lies on the left side and 0 on the right side. Okay, so first number, minus 1 and 0 has to be added and divided by 2. So it's going to be a negative half, which is exactly minus 1 by 2, correct? For the second number, what you do is you take negative half and 0. You add it and divide by 2. So negative half plus 0 divide by 2, which is negative half divide by 2, which is a negative 1 by 4. Why? Because negative half divide by 2 will be a negative half multiplied by half. So it's negative 1 by 4. Am I clear? And for the third number, what we'll do? For the third number, we are going to take negative 1 plus of negative half divide by 2, which is going to be negative 1 negative half divide by 2, correct? So that is, we have to find the LCM. So LCM is 2, so negative 1 by 2 minus half by 2, that is 2 by 2 minus half, which is equal to a negative 3 by 2 divided by 2, which is a negative 3 by 4. Hope I'm clear. So what are we doing? We are adding the corners and dividing it by 2. Okay. Am I clear? These are your extra questions.